welcome back. So in the previous part we spoke about the gradients and the applications, so parallel lines, perpendicular lines, and lines on and points on a straight line. And so what we're going to be doing now is we're going to actually be talking about lines and the equation of lines and just recap that a little bit because that's incredibly important. So we're going to be talking about lines. Let's get into it. And we're going to be talking about the equation of a line. Now, what we're going to be doing is we're going to be talking about the two things that describe a line. What makes lines different to other lines? So the first thing that makes a line different to another line is the steepness. So here we can see that ST is steeper than RQ. They're not the same line because they don't have the same steepness, right? And also, if I continue looking at steepness, this line RT is going up. This line has got a positive gradient. This line is going down. These are not the same lines. Why? Because the gradient is different. The second thing that describes a straight line is the positioning. So here I can see I've got two lines, ST and RQ. It looks like these lines are parallel, and so it's not the steepness that makes them different, but rather the positioning. Here I can see that ST is higher than RQ, and when we talk about positioning, what we're going to be talking about is the y-intercept. And so the y-intercept of RQ is lower down than the y-intercept of ST. If they were the same, they would be the same line. And so the two things that describe a line are the gradients, which is M, and the y-cut, which is C. So we've discussed this when we did functions. Our standard form is always going to look something like this, mx plus c, where m is the gradient and c is the y-cut. So here I've asked you guys to calculate the equation of this line. And so whenever we start a question like this, we always start by writing down the formula. You always start by writing down mx plus c because this helps me know what I must find. I must find the gradient, firstly, and I must find the y-cut. Now, does everybody see that automatically, by inspection, I know what the y-cut is? All right? They've told me what the y-cut is. They've told me that the y-cut is equal to 2. So I'm halfway there. All I now need to do is find the gradient. All right? What do I need for the gradient? Well, I know that the formula is y2 minus y1 over x2 minus x1. So I need 2 points. And I've only got 1 point. But isn't this also a point? They haven't told me what the x value is, but I know what the x value is. The x value is 0. And the y value is 2. And so I've got 2 points, and I can go and calculate the gradient using those 2 points. So let's jump straight into the gradient formula. What am I going to do? I'm going to go y minus y. So I'm going to go the y value of the second one minus the y value of the first one, 6 minus 2. Then I'm going to go the x value of the second one minus the x value of the first one. So it's going to be 4 minus 0. And what I'm going to end up with is 6 minus 2 is 4. 4 minus 0 is 4, and I know my gradient is equal to 1. So what have I done? I know what the gradient is, m is equal to 1, and I know what the y-cut is, c is equal to 2, and so now I have my line. Y equals, what is m? Well, m is 1 multiplied by x plus 2. That there is the equation of my line. All I needed to do was find the gradient and the y-cut. So let's move on to the next question. In this question, it says find the equation of the given line. So it's exactly the same question as the previous question. But what we see here, what makes this question different, is they haven't told me what the y-cut is. And so we're going to have to calculate that otherwise. But first, before we start any question, is we always start by writing down y equals mx plus c. Why? because it helps us know what we must find. I must find m and I must find c. Now, here I can go calculate m. How am I going to calculate m? Well, I'm going to use my gradient formula and I'm going to go y minus y. So I'm going to go 7 minus 1 and I'm going to go x minus x. I'm going to go 3 minus 6. Again, when I subtract something that's negative, I do that in brackets. And what I end up with at the top is 6. At the bottom, I'm going to get 3 minus minus becomes positive. So it's going to be 3 plus 6, which is 9. And so I know that my gradient is 2 over 3. And so I've gone and found the first part of my equation. I can't do this part by inspection, all right? So we're going to have to do this a little bit differently. But let's go back to what I know so far. I know that that's my equation. Y equals 2 over 3x plus c. I don't know what the y-cut is, but I definitely know what the gradient is. But also what I know more than this is I know that if I put in 3, the whole idea about a function, and let me erase that up top there because it's a little bit messy, but I know the whole point about a function is that if I put in 3, I must get out 7. That's the whole point about a function, is its input and output. And similarly, if I put in minus 6, I must get out 1. And so if I put 3 in here, if c is equal to 100, the answer is not going to be equal to 7. And so what I can do is I can put in 3. So let's do that. And let me choose a different color here. I'm going to put 3 into x. I'm going to get out 7. And now the question is, what must c be so that this equation is true? I've set up an equation, and now I can just solve for c. So let's do that. Here I can see the 3's cancel out. All I'm left with is 7 equals 2 plus c. If I subtract 2 on both sides, I'm going to get that c is equal to 5. Awesome. And so I've solved for my gradient, I've solved for my y-cut, and if I finish this question, y is equal to 2 over 3x plus 5. My y-cut, which I didn't know, is equal to 5. Awesome. What we're going to be doing now is we're going to be talking about perpendicular and parallel lines. Okay, great. So we're going to be going to an ad break, and I'll see you guys soon.